Hey everyone, Dr. Jenny Sue here. I want to share with you in this quick video how I think about the design process. Now, you all know I love science, but when I'm designing my lesson plans, I almost think like a chef. Chefs have all of these great ingredients at their fingertips and they know exactly how to put them in the right combination with the right amounts to get these fabulous dishes at the end. And that's how I want you to think about your science lessons. How do you take all of these great ingredients that you find, like labs, children's literature books, maybe some quick activities, instructional strategies, cooperative learning? How do you take all those pieces together and put them in such a way that you ensure all students are engaged and they're learning in your classroom? So come along and let's learn how I think through the design process. To design an effective science lesson, you have to have the right ingredients, just like an award-winning meal. This is where you need to go out and find, first of all, what are the standards that you're teaching? What do students need to know and do? And then you need to find some really great activities and resources. For this video, I'm going to use the 8th grade standards from Virginia, specifically related to chemical change. So when I go and look at the curriculum framework, I notice that students are expected to be able to distinguish between the physical and chemical changes, which means they have to know the characteristics of both. They're also expected to know how to use evidence to be able to identify those changes. So just with what I've read in this framework, I know that the activity that I pick has got to be very specific to those pieces in order to be able to work. So the first ingredient that I find for my science lesson on chemical changes is this rusty nails lab. And I like it, one, because a rusty nail is something in every student's real world, or maybe they've seen it around their home. So I like that idea of a real world connection for this content. But as I'm reading through this lab activity, first of all, I don't think it's really inquiry-based, and the other piece that I notice about it is it's really about an experiment involving fresh water and salt water, and probably looking at which one actually helps a nail to rust faster or rust more. So I'm not sure that part's going to really work with my lesson, but I do like the real-world connection. So I think I'm going to keep that idea. So I jot that down in my notebook. I like the idea of rust and the real world connection. I also wonder if I could use maybe a nail and a rusty nail and have the kids practice comparing and contrasting. Might be a good activity to have them practice looking at observable features. I think I'm going to keep that as well. So then in my notebook, I write down the idea of elephant's toothpaste. I remembered this activity, and the reason why I like it is because it's fun and it's really quick. But it also gives students a concrete example of a chemical change that's not too heavy in terms of equipment. And this stuff is fairly inexpensive. I can get peroxide at Walmart for 95 cents. Water bottles, I can just drink a bunch. I just need enough for each lab. We have the beakers, the graduated cylinders. Yeast, I can get packets of those fairly cheaply. And soap, I've got that at home, so I can bring it in. So I can get these things pretty fairly cheap. But I like this because when you mix peroxide with yeast, it produces this foam-like substance, and that's why you add the soap, because it makes it all foamy. But I remembered when I did this at a science camp that if you felt the bottle afterwards, there was a clear temperature change. So I could have the students observe before and observe afterwards. They could create a chart of all their observations of each material and then what's created afterwards. And that chart could be used when we start talking about the content. Okay, so I'm really liking the ideas that I'm coming up, the ingredients to this lesson. I really like them. I'm just going to have to put it in the right order in order for my students to really build off one experience to the next. So I know I need to think about this way of helping my students collect notes, right? They've got to write down, they've got to know the characteristics of chemical changes. Oh my gosh, we did a foldable in the lesson with physical changes, so we could just add to it now. And now we can actually have them write down the characteristics of chemical changes, that we get a temperature change, we get the production of a new substance, There's also a gas being created, and we also can see color changes, although those aren't really accurate. So a foldable would be the great instructional strategy for my students to actually take their notes, and they can decorate it. It'll be creative. So that could be something they could start in class and finish at home. We could also use our text to read, because if I remember correctly, there's a great piece about chemical changes that's really short, and I can actually put it through, I don't remember the online software, but I could, I know I have it bookmarked, but I could go through and I could simplify the text to make different reading levels. All right, so I know I've got a quick activity that'll introduce, or I could use it as an introduction for chemical change. And I like this idea of real world connection of the nails somehow. And I have an idea of how they could take their notes that's kind of engaging and not just boring, write down the notes, but they could actually create, add to that foldable piece because we did the physical science and they can elaborate on it. So now I just need to think of something that if I were to kind of think through that linear, that's what I'm going to do up to this point, how would I finish off this lesson? Oh, that's right. There's this mystery bags activity. Oh, that's really cool. It's where you take gelatin and mix it. You could have a bag of gelatin, a bag of alum, and a bag of baking soda. And then you could have bags that have mixtures of those combinations. And if I remember correctly, they add vinegar into it, and there's either a physical or a chemical reaction. Yeah, that's the perfect way. That really should be my ending of this lesson, because that would be an unknown mystery thing they'd have to solve. It would push them. They'd have to take what they learned and apply it to a new situation. Yeah, I'm really liking that idea as the ending, and I'm liking the elephant's toothpaste at the beginning. All right, so now that I have my ingredients, the goal becomes, how do I put those ingredients in the right combinations and the right position and timing in my lesson plan in order to help my students really make sense of what I want them to learn. And so now we talk about an instructional model that can help me lay out my pieces of my lesson plan. And so a lot of teachers use the Madeline Hunter method, where we're really looking at this anticipatory set. We're putting information in, we're modeling, we're questioning and checking for understanding, we're allowing students to practice, and then we're ending. Some teachers like the 5E model of instruction. It's often used in science education. But when you put them next to each other, they really go well together. So when I'm doing the anticipatory set, I'm engaging kids. So what could I do that would hook my students into learning? When I'm exploring, what could I be doing input-wise that my kids could be putting things in their head that would help them to remember? And then when I'm explaining, I'm actually modeling and I'm talking and I'm connecting those pieces together. And then as I go through guided practice or independent practice, this is where students are actually working either in groups or they're working by themselves to practice, to make sense of it. And then of course there's assessment that just gives me some indication of how my students did, so that if I need to adjust my next day's lesson or come back and review some pieces. But again, these frameworks just help me to put my ingredients into the right combination sequence to make an effective lesson. All right, so in the engage or the anticipatory set of my lesson, this is where I'm going to put my kids into doing something that gets their hands on it, and they are seeing the content that I'm going to introduce to them in just a little bit, but it's going to give them concrete experiences so their brain can have something to hook all this content onto. Okay, so remember, I had this ingredient of this real world connection, rust. And I thought, wow, that might be a great way for students to jump into this topic of chemical change by looking at it in the real world. So I found this great picture out on the internet, and I thought using the instructional strategy, see, think, wonder, it might allow my students, one, to be able to talk to each other, but I would also be able to hear their thinking and maybe get an idea. Have they seen rust in the real world? Do they know how it's caused? So again, see, think, wonder is where you give a picture or a video or a real object, and you ask kids to literally, in their notebooks, describe what they see. What are words that you could use to describe what you see in the object? And then the next part is to ask students, well, when you look at the picture, what real world connections do you think about? What personal connections does it make for you? And then the last piece is, what do you wonder about when you look at this question? So I was really curious what the students would say. So I thought this might be a great hook into my lesson sequence using the see, think, wonder. For the next piece, again, I really like that idea of having kids look at rusty nails, because I'm always wanting my students to practice making comparisons, compare and contrast, and maybe it might even could be a writing thing that students do. They take that information when they go to their language arts class, maybe they could use it for writing there. But I like the idea from that rusty nails lab of giving them a rusty nail and a clean nail and having students compare and contrast, and then just asking them, have you seen rust? Where around your neighborhood do you have rust? But again, working on those comparisons, those contrasting pieces, similarities and differences. I really liked that idea. All right, so I'm liking the idea of this rust, and then they go into that compare and contrast. So that see, think, wonder is probably going to take about 5 to 8 minutes, maybe 10 minutes max. And then the compare and contrast maybe take 10 more minutes. So I know that if I'm teaching a block of 50 minutes, I've got a little bit of time left. So I'm going to do the activity next with the elephant's toothpaste, because like I mentioned before, I remember this really gives some good characteristics of a chemical change. Plus it's just really engaging. Kids love it. They get excited. And we could make a chart that they could put in their science notebook. So the investigation question, because I don't want to just do this as a fun, mix these things together. So my investigation question could be this descriptive research question of what happens, what is produced when we mix peroxide and yeast together with soap. So there's their investigation question that we need to find an answer to, which will then lead us to talk about, they can make observations of yeast and the peroxide and the soap before and then afterwards. So we've got a nice comparison of before and after. And if I have them feel the bottle, they'll be able to feel a temperature change, because in the beginning it's going to be room temperature, and I know that it gets really hot as the reaction goes on. So that's a really good indicator of chemical change. So I really like that idea of putting this next, because when I go into the notes, this is going to be great for them to link back to this. Okay, so I know I've got to give my students notes. Like, they've got to have these characteristics, because in the previous lesson, we've written down the characteristics of physical change. So knowing that I'm going to use that mystery powders at the end, they've got to have information that clearly articulates how a scientist would identify a chemical change, that a chemical reaction has occurred. So we're going to use that Foldable for them to take notes. It's fun, it's creative, but that way we'll read the text, we'll make the notes, we'll link it back to the activity, so that when we get into this next piece of this mystery powders, they are ready to take these bags of mystery powders. I have a bag of gelatin, alum, baking soda, and then other bags mixed with those combinations, and they add vinegar, and they have to identify it's a physical or a chemical change. And so because they've taken the notes, they're prepared for it. And so this hopefully will be a great way for them to show me that they're able to take what they've learned and apply it to a new situation. And the last part in the lesson sequence is to take and do my assessment. So I'm evaluating and I'm assessing the students on how they did. It can be an informal or a formal evaluation, but maybe at the end of this lesson, I'm going to give them an exit ticket that gives them like an experimental data set of information, and they have to identify if they think it's a chemical change or physical change based off of what they read. It's a great way to end my lesson, and it gives me information. So just like chefs who pull ingredients and mix them into extraordinary creations, as a science teacher, you're creating lessons by putting the right pieces in the right order. And these instructional models, Madeline Hunter and the 5E model, just help us to think about how we place things and where we place things in order to get the most effective lesson to reach all of our learners. So thank you for joining me with Designing a Science Lesson.